Imagine waking up on a very different Earth. The Atlantic Ocean no longer separates continents. Almost all land is joined together. This is one giant supercontinent. Deep inland, deserts could stretch endlessly. Near the coast, life could thrive. One world, but two extreme realities. A superocean surrounds the entire landmass. Pangaea becomes a giant climate maze. So what if it never broke apart? Pangaea was once real. Earth's land once formed one great mass. But tectonic plates never stay still. In real history, Pangaea began to crack. Rifts slowly widened into shallow seas. Those seas grew into oceans. The continents drifted into today's world. India collided and raised great mountains. Antarctica moved south and froze. Australia became biologically isolated. The map changed over millions of years. That breakup changed climate, oceans, and life. But in this timeline, the cracks fail. Pangaea remains whole for deep time. No familiar modern oceans divide it. The interior lies far from moisture. The coasts receive rain and rivers. The center faces harsher temperature swings. Temporary lakes and dry plains dominate. Climate, not oceans, divides life. Small animals may not cross the interior. Wet plants may remain near coasts. Species can be isolated on one landmass. Pangaea is connected, but not simple. It becomes a labyrinth of climate. Coastal life grows rich and dense. A single superocean wraps around it. Ocean currents move in new patterns. Coastal seas become biological hotspots. The open superocean feels almost endless. Pangaea's coastline becomes a ring of life. But its center remains dry and difficult. Life is abundant, but unevenly spread. And evolution begins to change direction. When environments change, evolution changes too. Connected land lets animals spread farther. Successful predators could occupy huge ranges. But climate still blocks many species. Some animals would adapt to dry interiors. Others would thrive near wet coasts. Inland survival would demand toughness. Dinosaurs could evolve into different forms. Large grazers might follow coastal rivers. Smaller species could dominate dry plains. Migration would follow water and shelter. Deserts and mountains still create isolation. Modern continent-like separation would weaken. Unique isolated lineages may become rarer. Islands would matter less than today. Dominant species could spread more widely. Hardy plants could cover huge interiors. Wet forest life may stay coastal. Evolution branches would be fewer but larger. Pangaea creates vast connected ecosystems. Yet dry interiors become invisible walls. Mountains divide habitats from within. Rivers become lifelines across harsh land. Coastal biodiversity forms a living ring. Mammals could evolve along different pressures. Primates might remain trapped near forests. Life becomes wider but less separate. And human evolution becomes uncertain. The biggest question is humans. Would our branch appear at all? Human evolution depends on climate pressure. Forests and grasslands must shift together. But Pangaea changes that path. Africa would not be the same world. Primates might remain forest animals. Or intelligence could appear near coasts. Water-rich regions would matter most. Early humans might follow rivers. Migration would hug coasts and wetlands. The dry interior could block expansion. Coastal river mouths become survival zones. Temporary lakes become rare refuges. Tools might develop near rich habitats. Fire could still change survival. Human groups would cluster around water. The center may stay nearly empty. Climate zones replace ocean barriers. Cultures could form along long coasts. Pangaea's edge becomes a human corridor. Different habitats shape different people. There are no separate continents. But distance still slows expansion. Humans would follow animal pathways. So two futures remain possible. Humans may never fully rise. Or civilization begins along Pangaea's rim. If humans survive, civilization changes completely. One landmass replaces separate continents. Oceans no longer divide human worlds. People could spread by land routes. Rivers and coasts become first centers. Agriculture begins where rain is reliable. Settlements follow fertile corridors. The dry interior slows expansion. Pangaea's rim becomes a civilization belt. Ideas could travel much earlier. Tools spread from valley to valley. Languages mix across long distances. Crops move through connected lands. Animals follow human migration paths. Technology may diffuse faster. But disease also spreads faster. Conflict can travel farther too. Resources become strategic choke points. Separate histories become less isolated. Cultures still remain diverse. Deserts and mountains divide societies. Rivers become social backbones. Coastal hubs control exchange. Inland travel becomes difficult and valuable. Civilization forms a rim and river network. Every invention spreads through connections. Every crisis can spread the same way. And power begins to follow geography. On Pangaea, power follows geography. Rivers control food and settlement. Oases control inland movement. Mountain passes control connection. Coastal hubs control exchange. Land routes become extremely important. Caravans cross dangerous distances. Cities rise at natural choke points. Power spreads along fertile belts. But dry interiors interrupt expansion. Larger states may become possible. But holding them becomes harder. Resources shape political strength. Alliances form around corridors. Trade routes become the real map. Sea trade still matters deeply. Ports form a chain around Pangaea. Land and sea power merge. Human contact could happen earlier. Crisis travels through the same routes. Languages and cultures mix faster. Climate zones replace continental borders. Societies form around different habitats. Water becomes political power. Inland crossing becomes valuable. Pangaea is connected, but fragile. Every region depends on corridors. Its power map would be unlike ours. Pangaea changes biology on a global scale. Continents no longer isolate life as strongly. Australia-like isolation may never fully happen. Island worlds become less dominant. South America-like uniqueness may weaken. Natural laboratories become fewer. Strong predators could spread farther. Successful herbivores could range widely. Hardy plants could cover huge interiors. Competition becomes larger and harsher. Natural diseases also move more easily. Species meet rivals more often. Evolution becomes less continent-based. Many animals gain wider ranges. Climate becomes the main barrier. Mountains still split populations. Deserts separate wet and dry life. Rivers connect some species across distance. Coasts become biodiversity rings. Interior life stays more limited. Earth has fewer separate experiments. Dominant species may reduce uniqueness. Small islands still create odd life. Marine life follows the giant coast. Connected ecosystems intensify competition. Life becomes broad, but less isolated. Pangaea is one vast experiment. And the modern world becomes unrecognizable. Modern Earth would look nothing like ours. One supercontinent dominates the planet. Life concentrates near the outer rim. The dry center remains thinly populated. Coastal regions become civilization engines. Railways must cross impossible distances. Aircraft become essential for connection. Transport follows geography, not borders. Nations may form around climate zones. Coastal powers control the rim. River powers control food and water. Desert societies control rare crossings. Mountain gateways control movement. Sea trade circles the supercontinent. Land trade crosses dangerous interiors. A trans-Pangaea railway becomes legendary. Languages blend across connected routes. Cultures spread faster than before. Technology moves through the network. But crises move just as quickly. Resources create constant pressure. Connection brings cooperation and tension. Climate extremes shape daily life. Population gathers around water. At night, cities form a glowing ring. Great hubs rise where rivers meet seas. Everything spreads farther on Pangaea. The map itself rewrites history. Pangaea is more than a map. It is a different Earth system. Continents move across deep time. Tectonic plates reshape everything slowly. Oceans open where land pulls apart. Mountains rise where continents collide. Coastlines multiply when land separates. Isolation creates new evolutionary paths. Modern Earth became many natural experiments. But Pangaea would keep one giant stage. Its greatest wall would be climate. Its connections would change civilization. Every route brings opportunity and risk. Species would spread, but uniqueness may fade. Separation helped Earth become diverse. Human history might not unfold the same. The familiar world map would vanish. Our oceans would not be familiar. Our histories would be rewritten. Pangaea shows Earth as a moving system. The slowest forces create the biggest changes. A united world is not always simpler. Distance can be made by water. Or by heat, dryness, and time. Pangaea may have changed everything. Maybe even whether we exist. The supercontinent once joined the world. But its breakup shaped the world we know.